All right, welcome back. So there's another type of parametric equation that we work with a lot, and that's related to the unit circle. So let's take a look, remind ourselves real quick about the unit circle. Okay, so the unit circle is, of course, a circle. That's a bad circle. Try that again. So the better way is to draw the circle out here. I should know better. A little bigger. There we go. That'll do. That'll do. Okay, so we've all seen the unit circle before. We've all seen the unit circle. I'm trying to erase the middle, but it won't let me do that, so oh well. So we've all seen the unit circle before, and like things happen like where you've got this angle, but we're going to call it T now, okay? And this point we know is cosine T sine of T. This is, of course, assuming that our radius equals 1, which it is because that's the whole point of unit circle. Unit circle is circle radius 1 centered at the origin. Okay, all that other stuff, that's just angles you find on the unit circle. Okay, so this is actually a parametric equation. Okay, and it describes x squared plus y squared equals 1. Okay, so now we can actually do any ellipse in this way as well. So let's take a look at an ellipse. Okay, so I'm going to give you the parametric equations first. So let's say that we have x equals, I don't know, let's say 1/2 cosine t, and y is 2 sine t. Okay, and we're going to do, let's just say that we have 0 less than or equal to theta less than or equal to pi. Okay, so what we're going to say is, all right, we remember sine squared plus cosine squared equals 1. What does that mean? That means, in this case, 2x is cosine, right? Plus y over 2, that's sine, equals 1. So we get 4x squared plus y squared over 4 equals 1. Okay, now this part means we're only taking the from 0 to pi. So if we think about it just from the unit circle, it's just going to be the top half. And this is just going to be the top half of this ellipse. So I'm going to rewrite this just a little bit. So x squared divided by 1/4 plus y squared divided by 4 equals 1. And so what does this mean? This means left, right, it goes 1/2. Up, down, it goes 2. And we only need the top half. So this is going to be the top half of this ellipse. Okay? All right. You know what? I'm not going to go to the next video, but I am going to go to the next page. Okay? Why? Because there's still a lot more to do with this. There's a lot more to unpack with this. So let's say that we want to go counterclockwise around a circle. Okay? I'm sorry, clockwise. And starting, instead of at that point right on the right side, which all of these start at, right? All of our others, they started here. This one starts here. I want to start, let's say, at the top of the circle. And let's say we want to go around, I don't know, x squared over 4 plus y squared over 9 equals 1. Okay? So what's that mean? So that's going to go left, right, 2, up, down, 3. So our x of t is going to have an amplitude of 2. I'm just going to always use cosine first. Okay, you can use sine, but it's always easier to use cosine. But when I'm starting from the top, that's going to move everything at the top. That means I'm going to rotate it by pi over 2. Okay. I'm leaving a little space there for a reason. Okay, so this starts it from the top. But this is still moving counterclockwise. Okay, in order to get the clockwise motion, I'm going to need to add a negative sign on the t's. Okay, that's going to do it clockwise. Okay, why? Because if you think about it, okay, so when we're going around this way, and all we have to do to make it go counterclock or counter to go clockwise is to go negative t, right? So that's the negative t is what makes it go clockwise. Okay, here the t to t plus pi over 2, that moves the starting point. Now, this is a perfectly acceptable final answer for me. Okay, but you may see some other answers, so I'm going to try to explain why that happens. Okay, so one of the things to note is that cosine of pi over 2 minus t, that's actually equal to sine of t. Okay, the same thing. Sine of pi over 2 minus t equals cosine of t. You can see that just from looking at a triangle. Let's try that again. Okay, so if I have a right triangle here, okay, and this is my angle, okay, and this is pi over 2 minus the angle, okay, let's call this y, x, h. Cosine theta is x over h, but that equals the sine of pi over 2 minus theta. Okay. Sine theta equals y over h, and that equals the cosine of pi over 2 minus theta. Okay? So that's how you're going to get to solve some of these problems. Okay? All right, I'll see you in the next video where we'll start doing calculus with parametric curves.